Let's talk about inverses, and I'm going to work on a specific example of a function, 4x plus 3 over x minus 2. If you graph this using technology, you would see that it's 1-to-1, which means it does have an inverse, and we can tell that the domain of this function, you can have anything but 2. Plugging in 2 into the denominator would cause a lot of problems. It'd cause you division by 0. So everything but 2 is in there. And unless you look at the graph, it's kind of hard to tell what the range is. But if I find the inverse, then the domain of the inverse is going to be the range of the original. And the domain of the original is going to be the range of the inverse. So I already know the range of the inverse is negative infinity to 2, union 2 up to infinity. So let's go find the inverse. So first I'm going to start with replacing f of x with y. So I get 4x plus 3 over x minus 2 is equal to y, and then I'm going to swap my variables, which is essentially what you do. You change your inputs for your outputs and your outputs for your inputs. So anywhere you see a y, replace it with an x, and anywhere you see an x, replace it with a y. Well, now my goal is to solve for y. Well, I'd like to not deal with fractions, so if I multiply both sides by y minus 2, that'll clear my denominator, or you can think of just cross multiplying as another way that can work. From there, I'm going to distribute on the left-hand side, so I have x times y minus 2x is equal to 4y plus 3. I'm going to get everything with a y on one side. I'll go with the left-hand side. You can go with the right-hand side too. It doesn't matter which side you pick, but I'm going to go with everything with the y's on the left-hand side. So that means I'm going to subtract y, subtract 4y from both sides, and I'm going to add 2x to both sides. So I added 2x to both sides and subtracted 4y from both sides. So now you can see everything on the left has a y involved. So if you factor out a y from the first term, you're left with x, second term, you're left with 4. And then the last thing to do is to divide by x minus 4 to get that y all by itself. So this is my inverse. F inverse of x is equal to 2x plus 3 over x minus 4. So let me write on the same screen what they were. So my original f of x was 4x plus 3 over x minus 2. And we had figured out that its domain was negative infinity to 2, union 2 off to infinity. And we wanted to know what its range was. And we had mentioned that, well, whatever the domain is over here, that'll be the range of the original. And we had said that I already know the range of the inverse is going to be the domain of the original. So even though I don't really know what the graph of this looks like, I do know that its range is the same as the domain of f of x. Looking at the inverse of f of x, you can see the only thing that'll make me divide by 0 is 4. So the domain is everything but 4, which tells me the range of f of x is negative infinity to 4, union 4 to infinity. And again, this is because in inverse, you're essentially just interchanging your x's and your y's. You're undoing what you tried to do before, so you're swapping that relationship. So if you're domain in f of x, you're the range of f inverse. If you're the domain of f inverse, you're the range of f of x.